So in this video, we're going to solve a linear first-order differential equation using the method of integrating factors. This equation is already in standard form. That's the first thing that you should check anytime you use this particular technique. Standard form basically has the y prime in the equation by itself, and then any term that doesn't have y or y prime on the other side of the equation. So to proceed to solve this, the first thing we're going to have to do is find our value for mu. And in order to find mu, we are going to take the expression here in front of the y term, so not the y itself, but the portion of the equation that contains the function of x in front of the y. And so mu is going to be equal to e raised to the power of whatever this p of x value here is. So in this case, it's 2x dx. And so the p of x goes inside an integral in the exponent of the e. This is going to produce our integrating factor. Now, in some cases, you'll get a natural log function, and then you'll have to simplify that to get a multiple of x. In this case, when we integrate this, we're just going to get e to the x squared, e to the x squared. And that's going to be our integrating factor. Now, so if we multiply this through our entire equation, I'm going to copy the equation. And then every term is going to get multiplied by this integrating factor. So e to the x squared there, e to the x squared there, and e to the x squared there. Now, what's going to happen here is that the left side of the equation is going to become a product rule. So remember, our product rule is that fg prime is equal to f prime g plus g prime f. So in this case, our g, or again, the order doesn't particularly matter here, but this e to the x squared is one of our functions. Let's call it f. And then the derivative of that function, if I do the chain rule, I get 2x e to the x squared. And then our second function, g, is y. And if I take the derivative of that, I get y prime. So I have one function that's not a derivative plus with one function that is a derivative, and then the opposite. So that is our product rule side of the equation. And so this side of the equation is just going to become e to the x squared y, and then all of that primed. And then the other side of the equation will just be this guy. Now, in order to solve this, then, I can now integrate both sides with respect to x. On this side, with respect to x, that's just going to cancel the prime because I'm taking the derivative here with respect to x. And then I will actually have to do the integration on this side of the equation in order to solve the problem. So we've got integral of this dx equals the integral of this dx. And so on this side of the equation, we're just going to end up with the integral and the prime canceling. And then on this side of the equation, we're going to have to do integration by parts. So let's do that. So we're going to start with what do I need to integrate e to the x squared? That's going to be my dv, because our rule is that exponentials get to become the dv, and algebraic expressions will be the u part. Except in this case, we have to be careful because we're going to need to borrow one of these x's in order to integrate the exponential function. So we're going to have u is going to be, if I steal the 2 and an x, just like I needed up here, to get my 2x out front, I'm going to take what's left, which is negative x squared. And then du will be negative 2x. My dv is the 2x that I borrowed and the e to the x squared. And then v, if I integrate this, is going to be e to the x squared. (2x) dx. And we'll put my dx here just to be careful. Okay, so now applying my product rule, u dv is going to be negative, my integration by parts rule rather, is going to be negative 2x e to the x squared, negative x squared. So u is here, and then v is here, so uv minus v and du. So minus minus becomes a plus, and then integral of 2x e to the x squared dx. So we're not quite done. This integrates one more time, and we saw it up here before when we integrated previously. So this is now going to become, copy this line, and then this integral is going to become just e to the x squared plus our constant of integration. Okay, so now that we're at this point, now we need to solve for y. And so in order to solve for y, we divide everything by e to the x squared, or multiply by e to the negative x squared, either way. And so we're going to get y equals, now here if we divide by e to the x squared, the e to the x squared cancels. Here if I divide by e to the x squared, I get 1. And then for the c, I also have to divide that by e to the x squared, but that then becomes c e to the negative x squared, or c over e to the x squared. Now, this one right here, dividing e to the x squared, people have a tendency to treat it like it's canceling, and it is canceling, but canceling with multiplication and division cancels to a 1. It doesn't disappear completely. And here, sometimes people will forget to divide the constant by the e to the x squared, but you have to have the constant times a function of x here, because this is the part that solves the homogeneous part of the equation, and then this is the part that solves the non-homogeneous part of the equation.